is what we do. Here we go. Leading digit approximation, what does that mean? Fill this in. Leading digit estimation just means to read the place value. Place value of the first digit. Okay, that's why we say leading. So you look at the number and you look at the first digit and you ask yourself, what place value does that represent? So here's an example. This is from your textbook, from the Year 11 textbook. Year 12s do the same, but you guys do a lot more and they do a lot less. Yeah? Let's have a look at the question 6a. This is from your textbook 5.2. You have a look at 12. What's the first digit? The first digit I see is number 1. But that 1, where is it placed? You see, this first digit 2 is your ones. Then the number 1 represents which one again? It's your, starting with T, tens. Very good. So this is your tens. So when the question asks you, round each of the following numbers to the leading digit, all this question's asking you is round this to the nearest tens. So if you think about tens, when you count tens, this is how you count tens. You go 10, 20, 30, 40. Sorry, we should start off with 0 as well. So 0, 10, 20, 30, 40. That's counting by tens. So when they say round 12 to the nearest 10, 12 somewhere between 10 and 20. So when we say round to the nearest 10, we're asking you, which one is it closer to? Is 12 closer to 10 or is 12 closer to 20? Now logically we know the answer is, it's closer to 10. 12 is closer to 10. Yeah, so the middle point is 15. So it's closer to 10 because 12 is on the left side rather than the center. So here, when they say, what is the rounded value? You would say, well, 12, rounding to the nearest tens, we can see the tens multiples. We can say, oh yeah, that's actually just closest to 10. Okay, now that's a theory point. We're not actually even doing an application yet. So I'm just getting the theory across so that you understand when they say leading digit, what do they mean? It just means the first digit. What place value is that? Rounded to the nearest value. And I'll show you why we do that. You actually do that realistically already, but you probably just don't realize you're doing it. Okay, I'll show you an example soon. Let's do another one. Let's do B. B, first digit again, is a 2. But that place value, what place value is that sitting at? Let's go with Liam. First digit is a 2. What place value is that? So you got ones, tens, hundreds. Ones is the first one. So units. So we say this is the ones. So the next one must be tens. Tens. Very good. So we got 10. So that's 20. So that's your tens. So then you go through the tens multiples. You go 0, 10, 20, 30, 40. Now 23. 23 is somewhere here. True? 23 is clearly between 20 and 30. But which of these tens is it closer to? 20. Very good. So the answer for B, we say rounding to the first digit, it's closer to 20 than it is to 30. Let's have a look at C. So C is the next one. C is the next one, first digit. Georgia, what's the one here representing? Hundreds. This is representing hundreds now. So you got units, tens, and hundreds. So that's 3 units, 50. 5 represents 50, so tens. That's 100, so it's your hundreds column. So you're rounding to the nearest 100. So if you count it now again, multiples of hundreds is 0, 100, 200, 300, 400. And you ask yourself, 153, where is that roughly sitting? So 153 is somewhere here. Now you're going to ask yourself, is 153 closer to 100 or is it closer to 200? Which one would that be, Estella? 200, because it's just past the 150. It's just got 3 units extra than the half. So that's why we say it is closer to 200. Had it been smack bang on 150, we still round it up. It's kind of like saying 9:30. So the 30 line is actually closer to 10 o'clock than it is to 9 o'clock because we've already gone halfway across. So mathematically and conventionally, we say once you hit the halfway point, we round it up. Okay, so every time you hit the halfway point, we then just round it up. So in this case, we can see that you're already past the halfway point between 100 and 200. 150 is the middle. So 153 brings us up. Okay. Then the next one, D. D has a digit. The first digit is a 1 again. But what place value is that? Let's go with Michael. Thousands. Very good. So this is your thousands column. And so you then go with your multiples of thousands. So you start off with 0, then it's 1,000, then it's 2,000, then it's 3,000, and so forth. So you ask yourself, well, where is 1,388? Clearly, it's somewhere between 1,000 and 2,000. So then you ask yourself the same question again. Which one is it closer to? Is 1,388 closer to 1,000 or is it closer to 2,000? What would that be, Ashara? 2,000. Oh, well, let's look at the numbers again. 1,000, because 1,500 is the middle, so 1,300 is on the left. So we say it is closer to 1,000. Does that make sense? Okay, so I've done 4 examples. I don't need to do all 6 examples for you to understand, but I wanted you to understand what they mean by leading digit. Okay, so that's the theory. That's what you would have done from year 7 to 10. We just don't call it leading digits back then. So now, when would you use this? What kind of application can they give to you? Here's a quick one. Sometimes you just want to do quick maths. It could be you're buying something that weighs 74,852 grams. Make it kilos, for example. And you're buying 489 units of that. Now, if you had to sit down and roughly estimate, because you don't have a calculator with you, if you had a calculator, cool, punch it in, everyone's done. But if you didn't have one, if we just had to estimate roughly, how much would this cost? Right? So if it's $74,852 for something that you're buying. So let's say it's a car and you own a car company and you're buying 489 because you're ship holding mass cars. You want to buy that so you can resell it afterwards. What's the estimate cost? You see, you can sit there and do it on a calculator and figure out exactly how much you need, but that's not what we normally do. Sometimes we kind of estimate roughly what it is. So one of the best ways to do it is you look at this and you say, well, 74,000, that's too hard to compute. So we look at the first digit and we say, well, that's already 70,000 because that's 7 represents 10,000. So this represents roughly 70,000. But you see what I'm doing is I'm actually rounding to the first digit because 74 is closer to 70,000 than it is to 80,000. So that's what I'm doing. I'm actually rounding normal. And you guys probably do that already when you're buying stuff. You get your, cost and sometimes like $1.59 times and you buy, 6 packets of lollies. You kind of estimate that. You're like, oh, well, it's about $1.59. So let's say $1.50 if you can work with halves, or you might just round it up to 2. And 2 times 6, you need about $12. So that's what you would do naturally. Then we're doing the same thing, just on a larger scale. Same idea. So 70,000 is easy to work with. And then 489, well, 4 represents the hundreds, but 489, is that closer to 400 or is it closer to 500? 500. So it's much easier for us to roughly estimate and say 70,000 times 500 is much easier to do because we know that 7 times 5 is 35, and then we just count the zeros. We've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What number is this? 35 million. So if I had to estimate this for you, if you were buying cars that were roughly $74,852 per car, and you're buying 489 cars, roughly how much do you need in your bank or loan? You might probably need about 35 million. I don't know how that works, but that's a rough estimate. It's a give or take. That's the purpose of rounding and estimating, yeah? So here's the example. So now that you understand what it means by rounding to the leading digit, I want you to have a look at this exam from 2024. This is what the year 12 is doing, which is if your goal is to get the ATAR, you're training for that. So let's read this one now. This question, a company purchased 8 printers. So in this scenario, I'm buying printers. Each printer costs $92. Okay, so I know each printer is 92. A total cost is calculated using leading digit approximation. So what they're trying to say is, approximate this. $92. Let's work this out. That's very specific. It's 92. So if we were to round it to the leading digit is the first digit here. So 9. What's the 9 representing? The tens. Very good. And the tens, now we've got 10, 20, 30, 40, 50, 60, 70, 80. So 90, you end up with 90 versus 100. That's the next tens. Which one is it closer to? Is 92 closer to 90 or is it closer to 100? 90. So this is the first skill. The first part was to say, all right, it's roughly 90 bucks. 92 is roughly 90 bucks. The question is asking percentage error. Now, I know you haven't yet got to percentages yet when we get there, but I like to do this so that you can see how we're using multiple skills to solve a very common problem. So here we're estimating it's roughly 90 bucks. But the actual cost is $92. How far off am I? By rounding that, how much am I losing? $2. Very good. So how do we know that? We will say, well, 92 is how much it cost, but I round it down just so that my calculations are easier. 92 minus 90 gives me $2 difference.
Wouldn't you just add the 2 at the end of your calculations?
Depends on how many you buy. So if you buy 10 of them or 8 of them, then now it's 8 times 90. You're losing $2 every time you buy a printer. That's very good. So what they're actually asking instead, though, is they're asking for a percentage error. So they want to know when you buy 8, what's the real cost? How much should have actually cost? Because if you bought 8 printers, if you had a calculator, you would have just done 92 times 8. That's the cost for the actual real price. But you're doing an estimate because it's easier for you to do a quick calculation. So if you bought 8 of these, this is much easier to calculate in your head. What's 8 times 90? Take your time. 8 times 9? 72. Add on the 0. So here we go. This is now 72. 8 times 9 is 72. Add on the 0. It's roughly $720 to buy the printer that's roughly 90 bucks. But we know it's not actually 720 because we're $2 off every time. So when they say percentage error, we actually now need a calculator. Remember, you get a calculator on the exam. So we want to know now, what's the actual difference in cost? So the real cost, 92 times 8. So if you've got a calculator, we'll do it. I'll do it on a calculator so you can see it in practice as well. Remember, you can only use a scientific in the exam. So you can't use your CAS. Your CAS are only for methods and other classes. So we're going to work this out on a calculator. I'll do a simple calculator like this one. Let's go. 92 times 8. 736. So now I know this is the real cost. How far off am I? How much is the error? How much am I missing? How much am I missing? 720 is what I estimated, but the real cost is 736. So how do you work it out? What's the difference? 16. And again, if you didn't know, you can just subtract it on the calculator. You don't have to do it by hand. Remember, I'm trying to avoid doing by hand. I'm trying to get you to think how to use the maths that you know, add, subtract, multiply, divide, to calculate the difference. Yeah. So we know it's $16 difference. Now, in reality, that's good. If you're on a small scale, just doing yourself, you're happy with the 16 bucks. It makes sense. But when you're opening up your own business and you're running something huge, like imagine Apple, they're not calculating on per phone they sell. They're looking at the revenue and they do an estimate. They're like roughly 30% profit or 20% drop in their shares or whatever it is. They're using percentages to figure out on a big scale because it's just too many numbers in between to actually work with. For us, we're happy with 16 bucks to know that we're at $16 off. But in a big company later on, if you guys happen to pursue that way, you prefer percentage error. How far off am I? Am I about 5% off? Am I about 10% off? How do you work it out? Now the logic is, to work it out, it's just basically $16 out of what you started off with. So you started off with 92 bucks. Oh, sorry, you started off with 736 bucks. It's $16 out of that 736. Get me? So you've got, this is how much it should cost. This is how much it should actually cost. This is how much you're missing. So if you want to work it out, it's what proportion is it? It's $16 out of your original, which you should have costed 736. 16 out of 736. You don't need to know how to do this as a percentage by hand. You just need to know how to do it on a calculator. So here we go. Let's divide it. 16 out of 736. Out of means divide. So let's use our calculator. Here we go. $16 is what you owe. Oh, like the missing $16 out of what you should have got, which is 736, gives you a decimal. But that's why when we do percentages, percent, per means every, cent means 100. So you need 100 of them. So if you need 100 of those, instead of adding it 100 times, we just times it by 100. So here, if I times by 100, how much percent are you off? You're about 2.17%. And that for a company makes a lot of sense. For a company, if you were like going out and telling them the investment earned, you're slightly 2% off. It's a very small scale. It's okay. But if you told the company that you were 21.7% off, they'd fire you. Right? So it makes sense why you're trying to convert it to percentages, so people can then compare. Is it a bad sale or is it a good sale? Right? So what did I just do just now? So write these notes if you weren't sure how to do percentages. We will get to that topic later on next year, but I'm just giving you a heads up on how we're doing it. So here, how do we do the percentages? I did 16 on my calculator divided by 736. And then I times by 100. Now let's look at the logic that I went through. This is how much we were missing. This is the error. Missing or error. This is out of what you actually owe. That's how much it should be. So this is original. So missing is the error. 736 is out of what you owe. And why did I times 100? Because percent literally means that. Per means every cent means 100. Century. That's what I'm doing. I'm actually just saying this is how much I owe, how much I'm missing out of what it should have cost. That gives me a proportion, and I need 100 of them. That's how I got 2.17% on the calculator. Write that down just as a sort of FYI. But can you see how I used very simple mathematics to calculate a very simple small problem, but you can scale that. You will probably use that for your taxes. When you're working out your taxes, like percentage, how far off when you're working from home. If you're working out how many hours roughly per week, you do an estimate. And when you work out the number of hours, you work out the number they tell you. Hours times 0.612, or the electricity use, you work out the percentage. Work out the percentage. So this is how you do it. Missing, or whatever that value is, difference divided by the original times by 100. That's the general formula. When we get to that topic, I'll do more of it. But in one question, there were two skills that you were doing. Rounding, so learning how to round to a leading digit. And number two, percentage error. This is why half the students got this wrong, because it's not that they didn't know how to round. It's this bit. And understanding what they had to do. Okay, so percentage error, 2.17 was the answer, A. Does that make sense? So that's the topic. When you go through the exercise, it doesn't feel like that. The Year 12 textbook is more like that. The Year 12 textbook gets you to think about the mathematics, what you do, and you combine them all together. And then you solve your problems. That's what foundation maths is all about. And that's why it's so exciting. It's such a good subject to actually teach you something that you will walk out and hopefully you feel more confident in mathematics for your own life. Starting a business, I don't know, buying something and finding a profit out of it. That's what that's for. Okay? So today's lesson, you have the choice of trying some practical examples. I just did it through ChatGPT to make out some exam style questions. So it's more applicable because it's not in your textbook. But if you like to just practice from the beginning, then go through that booklet I gave to you. This has the textbook questions. So this booklet, if you go to 5.2 rounding, that has some of the basic questions just to get you started on the theory. But I'm more about the application because that's what the exam is going to be next year for those who want to get an ATAR and who wants to do exams. For those who just want to get an S for the subject, like I said, turn up to my class, do the exercises, and if I can see that you understand how to round, how to do percentages, you get your S. That's as simple as that. I just need you to turn up, I need you to show me what you know, and I'll give you the S so that you can get your BC certificate. And then you can then go out, do whatever it is you want to earn money. Yeah? But for those who want to do an ATAR, get an exam, get a particular score to get into a university entry, that's the expectation. application. It's all about problem solving. It's all about tying every maths that you know and solve a problem. That's what the exam is. So on that first day, when I gave you this 2024 exam, it's for you to see what kind of problems you're going to be dealing with. Cool? All right, so that's our session for today. I'm going to stop the video, and then I'm going to show you what it looks like. So I'll stop the video.